half adder. It is a basic digital circuit that adds two single bit binary inputs, means 2 bits are added by using this half adder, and it produces two outputs, which is a sum and a carry. So it uses one XOR gate, exclusive OR gate, and one AND gate. So XOR gate is used for doing sum and AND gate is used for carry. But it cannot handle carry in from the prior stage. If a carry is coming from previous stage, अगर कोई कैरी भी साथ में आ रहा है बिट्स ए एंड बी के साथ, तो वो ये हैंडल नहीं कर सकता. इट्स प्रॉब्लम ऑफ दिस हाफ एडर. नाउ लेट्स सी how it works and what is the diagram for. So this is basically half adder. This half adder have two inputs, bit A and bit B. These two bits are input and it will produce two outputs. One is sum of these bits and other is the carry. If there is any carry, that will be given at this output. And so it means a half adder has two inputs and two outputs. Inputs are A, B and output is sum and carry. Now see the truth table for this half adder. Now let's see this truth table. So this is basically truth table for half adder. Here two are input bits A and B. So what can be value of A and B? So we will write B can be 0, 1, B can be 0, 1, and A 00 and 11. So these are the four options starting from 00 and ending at 11. So four options are possible if we give two inputs. अगर हम इसको दो इनपुट्स देते हैं तो चार ऑप्शन ही हो सकते हैं. आइदर ए की वैल्यू 0, बी की वैल्यू 0, देन A0, B1, देन A1, B0 एंड A1 एंड B1. सो सिंपल वे है लिखने का कि फर्स्ट बी की वैल्यू लिख लो 0, 1, 0, 1 and then for A double zeros and double ones. So this is the combination. If we add 0 and 0, what you will get? You will get 0 as sum and 0 as carry. If you add 0 plus 1, so it will give you 1, that is carry will be 0. If you add 1 and 0, you will get 1 as sum and carry as 0. If we add 1 and 1, 1 plus 1, you know 1 plus 1 is 1 is 0. So 0 will be the sum and carry will be the 1. So we have these combinations of input A and B and what we get as sum and carry as output. Now we have to make equations for these sum and carry. So let's do it by using K-map. So first we will do it for sum. We will draw a K-map for sum. So because for sum the inputs are A and B, so these are the two variables. So we will draw two variable K-map. So simply let's draw a two variable K-map. A, B. A value can be 0, 1. B value can be 0, 1. And where it is 1 at 0, 0, this is 0. So no need to mark at 0, 1, this is 1. 0, A is 0 and B is 1. This box mark as 1. A is 1, B is 0. A is 1 and B is 0. Mark it as 1. So this is 1. So at 1, 1 it's 0. So no need to draw. So we have only two markings in this K-map. So this is the K-map for S sum. So they can't be paired. They are at locations which cannot be paired, so mark it as singular, mark it as single. So you will get the equation S is equal to, for this you will have in this side value of A as 0, so A will be written as bar, and on this side value of B as 1, so B will be written as B as it, plus for this one, and this side the value of A is 1, so we will write A, and on this side value of B is 0, so we will write B bar. So this is the A bar B plus A B bar. So this is the equation of A exclusive और B. So ये इक्वेशन वही होती है, ए एक्सक्लूसिव बी को ऐसे ही लिखते हैं हम, ए बार बी फर्स्ट का बार सेकंड एज इट प्लस फर्स्ट एज इट सेकंड का बार. सो दिस इज द एस इज द बेसिकली इक्वेशन of exclusive OR. So exclusive OR can implement the sum. So this is XOR gate on A, B. So अगर हम XOR gate लगा दें A और B पे, we can get the sum. Similarly for carry we have same two inputs A and B. A value A and B की values वही 4 values 0 0 0 1 1 0 and 1 1. The output is 0 0 0 and 1. So we have to make a K-map for this also. So we will make K-map for carry. A, B, value of B can be 0 1, value of A can be 0 1, and now we have to substitute. For 0 0 it's 0, 0 1 it's 0, 1 0 it's 0, only for 1 1 its value is 1. So for 1 1, 1 means here A is 1 and here B is 1. So this box will contain 1. So only one box will be marked, and so pairing is not possible, so take it as individual. And for carry we write C. C is equal to, so this is K-map for carry, that is C. So C is equal to, we will do C here. For this 1 we have value 1 of A, so we will write A, and in this side we have a value 1 of B, so we will write B. So for one value we write it as it, means we don't use complement, and if it has been 0 we have written as A bar. So अगर उसकी वैल्यू 1 है तो हम उस वेरिएबल को as it लिखते हैं A, and if on this side the value of B is 1, so B is as it. So this is AND gate operation. So AND gate on A, B. So for carry we use AND gate. So both K-maps we have. This is for K-map for sum, and this is the K-map for carry. This is the equation for sum, which is exclusive OR gate, and this is the equation for carry, which is AND gate. It means अब इसकी सर्किट डायग्राम जो है वो कैसे लिखनी है, वो हमने सर्किट डायग्राम इसकी हमने गेट एक तो एक्सक्लूसिव और लेना है, और इनपुट देनी है इसको A एंड B, एंड यू विल गेट S इज इक्वल टू A एक्सक्लूसिव और B. अनदर हमने लेना है वो AND गेट लेना है. सो AND गेट इसमें इनपुट्स वही देनी है A एंड B, and you will get output carry as A B. So for the input A and B, you will get S as exclusive OR of A and B and carry as multiplication of A and B, which is AND gate. So this is the circuit diagram for half adder. So in this way you can make half adder.